We're going to do another triangle congruence theorem today. Today we're going to talk about angle side triangle congruence. So you're labeling pages 54 and 55, and evidently I've forgotten how to spell congruence. And I keep forgetting to put it 6.2. So 6.2, angle side triangle congruence. Just like before, you're going to go back at the end of this video and go fill out your foldable that lists all of them. That's the one back here. This one. We're almost done with it. We've done side, angle, side. We've done side, side, side. We've done angle, side, angle. We're doing angle, angle, side today. We're doing hypotenuse, leg in a couple of days. Okay. All right, so you're going to need some pages out of your book. You're going to need 284, 285, and 288. Right there, right here. 284, 285, 288. I'm going to need some scissors. I didn't get any out. I don't know where my scissors are. That's not a good thing. I gotta go find my scissors. So rip those pages out. Homecoming bucket. Alright. From 284. You are cutting out the theorem. That's from 284. From 285, you're cutting out A and B. Now, the thing with A and B is A and B wants you to prove using a flow chart proof, and we don't use those. They're very weird. We're not doing that. So we're going to cut out that piece, and you'll see what I mean in just a second. Okay, so go ahead and glue this down. There's the theorem. All right, and then from 285, I'm going to cut off just a little bit more so it'll fit. You're going to cut out A and B. You can cut them together or separate. That doesn't matter. But they both go on 54. We'll talk about what goes on 55 in a minute. We're going to do these first. So we're going to go ahead and start with proofs. I know the last few that we didn't go ahead and start with proofs, but now that's, you know, that we've done them for so long, we're going to just go ahead and start with proofs. We're going to get better at proofs. Okay, so angle side congruence theorem says if two angles and a non-included side of one triangle are congruent to the angles and a non-included side of another triangle, then the triangles are congruent. Let's talk about the difference between angle side and angle side angle. So I'm going to flip so you can see the difference. Here's angle side. It's an angle, and one of the sides that's not connected. So it could have been BC or it could have been AB. While angle side angle is the one with it in between. So angle side is one that's not in between. Okay, that's the difference. So In example A, we're given that AC is congruent to EC. We're going to go ahead and mark that, and we'll put it in our given. We are also given that M is parallel to N. You mark that by putting a little arrow. Okay, so we're going to go ahead and write that. Statement. Reasons. I hope this is enough room. I probably should have cut them separate to make sure it is, but oh well. We have two givens. The first one is that AC is congruent to EC. That's our side. We'll need two angles. Our other one is that M is parallel to N. Anytime they give you that something is parallel, more than likely you are going to use one of the theorems from page 38, because these are all the parallel line theorems or postulates. More than likely we're going to use one of these when they say parallel lines, which is why we have this notebook, so we can go back and look at the theorems and postulates. All right, so we have one side. We have it here. We need some kind of angle, okay? So first of all, we're going to name the angle that I like to name the most, and that's the vertical ones, just because we almost always think, oh yeah, vertical angles. So we've got vertical angles. That doesn't mean we had to name the vertical angles. I'll talk about what else we could have done in just a minute. So let's say ACB is congruent, ACB, ECD. That is because they are vertical angles. So by the vertical angles theorem. Okay. Now, number 4. So we have a side. We have one angle. We're going to need another angle. Now, we're learning angle, angle, side today. It is possible to prove this with angle, side, angle, because we could say E is congruent to A because they are alternate interior angles, because these are parallel. However, based on the same logic, we're going to be able to prove B and D are congruent. Now, we want to prove B is congruent to D because we are using angle, angle, side. If we were using angle, side, angle, we would say E and A. Angle, side, angle. Which means later, if you're doing your homework, I don't care what you use, because it's important that you understand that it is possible to do these with a lot of different things, okay? So number 4, though, we're going to say that these two are congruent. And while that's the only angle, like in a triangle, we are going to use 3 letters because there's more than one thing going on in this picture. So angle ABC is congruent, ABC, to DEC. Is it not? ABC, sorry, EDC. Because they are alternate interior angles, and that's the alternate interior angles theorem. Yes, that's all that shortcut. Remember, that came, in case you are confused about some things, right here. Alternate interior is they're on the inside and they are opposites. These are on the inside and they are opposites, even though we've got this triangle going on here. Okay, I have an angle, and a side. So triangle ABC is congruent to triangle EDC by angle, angle, side, triangle, congruence theorem. Okay. Letter B. I want you to try this one on your own. You've got parallel lines, which means you're probably going to use That's not it. This one, you're probably going to use something in here. It's on page 38. Okay, statements and reasons. So you should have paused the video. We have three givens. CB is parallel to ED. We're going to mark that. CD is parallel to ED. We know that AB is parallel to CD. And we know that CB is congruent to ED. So there's our segment, CB and ED. So not only are they parallel, they're also congruent. Okay, so we're going to need some angles. Since these two are parallel, CB and CD, we actually know that this and this are congruent. We'll have to figure out what type of angles they are. So let's look. It's one of the top four. Let's open them up. So let's look. Here and here is, this one is corresponding angles theorem. So it's corresponding angles theorem. So A, C, B. They look like they are right angles, but we don't know that, so we can't say they are unless we know it. ACB is congruent to CED by the corresponding angles theorem. All right, we want angle, side. So we don't want this one because that'd be angle, side, angle. Angle, side. Well, we need to see then, do we think these two are congruent? And let's think, we got two parallel lines now cut by a transversal. They are, same reason. So BAC is congruent, BAC, to DCE. Also corresponding angles theorem. All right, I have an angle, I have a side. So triangle ABC is congruent to triangle CDE. This one, it was not possible with the given information to prove it any other way, even though letter A was, this one was not. It is not possible to prove that B and D are congruent before you prove that the triangles are congruent. So we couldn't have used angle, side, angle, or anything else. We didn't know anything about any other sides. All right, so you have page 288 also torn out. We're going to cut from there now. Basically, you're just trimming it. So from 288, we're going to put this on page 55. You're going to trim it down so you have the diagram and 7 and 8. Doesn't matter if you have a lot of space down here or not. I'll glue this in. Okay, that's crooked and it bothers me. It might not bother you. Okay, so refer to the diagram to answer the questions. It says, given A is congruent to D. A is congruent to D. And B is congruent to E. B congruent to E. We have to answer these questions. Number 7. This technically, 7 and 8, while they work with the same diagram, don't necessarily correspond. Here's what I mean by that. 7 and 8 are going to have us show that it's angle, angle, side, and then that it's angle, angle, side, okay? Obviously, we don't normally have to do both. It just wants you to understand that both work, okay? That not only does angle, angle, side this way work, but so does angle, angle, side this way, okay? So, number 7, show that the two triangles are congruent using the angle, angle, side theorem. We already have two angles, so all we're missing is the side. So in 7, it wants us to show that based on BC being congruent to EF. So we are going to find the length of BC and the length of EF. And we are going to use the distance formula to do that, in case you've forgotten the distance formula. Or remember the Pythagorean theorem shortcut. It is x2 minus x1 squared plus y2 minus y1 squared. So in case you've forgotten it, there it is. So BC, X for B, so either, I'm going to list the points, B and C. B is at -5, 5. C is at -1, 2. And E is 1, 2. And F is 5, -1. Okay. Okay, so let's set it up. BC. So x2 minus x1, and I have plus because negative, negative makes positive, plus y2 minus y1. I'm going to plug that in the calculator just like it is, perfectly like it is, so that I don't make any small mathematical mistakes here. This is my calculator pulls up. No. Okay. Let me make sure it's always at the front. Okay, so second x squared, and I've got 1 plus 5 squared plus 2 minus 5 squared. And that's 6.7 I'm going to round to. Okay, now let's find EF. Distance formula is x2, so 5 minus 1 squared plus -1 minus 2 squared. Okay, again, I'm going to type it in. Second x squared, 5 minus 1 plus -1 minus 2 squared. And that is 5. Did I do that right? 5 minus 1 squared plus -1? No. Look. Yes. They should be congruent, so maybe I've done something incorrect. Let's look at B. -1, -2, -3, -4, -5. 1, 2, 3, 4, 5. Okay, this point's right. C, negative 1, 2, that point is right. E, 1, 2, that point's right. F, 1, 2, 3, 4, 5, negative 1, that point's right. Let's make sure I set it up right. I did not. Look at this right here. So let me go grab some white out. I'm not changing or editing this video. It's good for you to see that sometimes mistakes happen. If you do something like I do, it is a good idea to label your points. X1, Y1. That's the mistake I've made. X2, Y2. X1, Y1. X2, Y2. Here's what I've done. This is X2. This is X1. This is Y2. This is Y1. This one's fine. Still looking for the mistake. Did I type it in the calculator correctly? I did not type it in the calculator correctly. I've set it up correctly. Look at this right here on the calculator. If I go up and grab this, here's my mistake. I didn't put in negative 1 right here. So one little mistake, we'll get it. I needed a negative 1 plus 5. Now, that's 5. So small thing there makes the whole thing wrong. So label it. I did set it up correctly. What I did not do is plug it in the calculator correctly. So check your work. So therefore, BC is congruent to EF. All right. And if you found the mistake before me, good. I'll leave this in here so that you see that mistakes happen to everybody. All right, number 8. Same thing. We are going to be working with the other segment. So we actually proved that BC is congruent to EF already. So we already have that the triangles are congruent by angle, angle, side. But the purpose of this question is to show you that this works for other values as well, okay? So we're going to find this for A, C, and E, DF as well. So we're just going to list A and D here. Okay, so for number 8, and I want you to pause it and try it on your own, make sure I don't make mistakes. A is at negative 4, 0. And D, smudge that, is at 2, negative 3. And we've already got C and F up here. And I'm going to go ahead and leave C and F as X2, Y2, and I'm going to make A, X1, Y1, and D, X2, X1, Y1. So label them just in case you never know what's going to happen to you. All right, so AC negative 1 plus 4 squared plus 2 minus 0 squared. Just make sure I type it in the calculator appropriately. The only bad thing about this not being in real time is you can't say, wait a minute, you messed up. Negative 4, there we go, messed up already. Negative 1 plus 4 squared plus 2 minus 0 squared. Got 3.6. Okay. DF. So anytime you have something on a coordinate plane, you are going to find that segments are congruent by doing this. All right, DF. So 5 minus 2 squared plus negative 1 plus 3 squared. make sure I type it in right. Second x squared 5 minus 2 squared plus negative 1 plus 3 squared. 3.6. So AC is congruent to DF. By the way, I know I made a mistake on number 7 when they didn't come out because it says show that, not determine if. So they were supposed to be congruent. So we also showed that these two were congruent. We didn't have to because, we'd already had these 3 pieces, but it wanted you to see that, hey, it works either direction, okay? We're going to do the last triangle congruence theorem this week, not tomorrow, but soon. So I'll see you for that. Go back and fill in your foldable with the angle-angle side triangle congruence theorem.